Let's get started. So make sure you follow along. It's gonna involve lines still, but now we're talking about inequalities. So how do you know you're dealing with an inequality? You're gonna have one of these symbols in your instead of just an equal sign like we're used to working with equations, you're gonna have one of these inequalities there. Oh, you don't have the booklet? Okay. So the inequality does not just deal with the points on the line, but it deals with, watch this, when you have an inequality, you deal with the points that are either above or below the line. You're not just about the line, you're above or below the line. And we indicate this by shading, right? We'll shade the area above or below the boundary line. So that's how it's going to change. So if you have, if I give you something like this, right, that inequality there, the boundary line of this inequality is found by simply, watch what we do with that inequality. We actually do turn that into an equation to find like that line that will cut the graph in two planes. We call them planes or like areas, okay? So the boundary line is this, and we split it into two planes for that reason. So when we shade, okay, you got to watch out. When we shade in this unit, we'll use regular or reverse shading, okay? And how is it different? Just listen carefully to this part because this causes confusion later. But it's going to make it easier if we understand what's happening, okay? Textbooks, computer software, anything like that will always use regular shading. So the true region, the region that we want, is the one that we're shading in, okay? But computer softwares and so forth, they have color codes. So we can actually distinguish, oh, this is true region. Because once you have many true regions and they all overlap, you're going to be like, wait a minute, like which one is the true region here? Because there's many going on. So what we do is I use a technique, use reverse shading, where we shade the false region. So we're basically going to shade the areas we don't want so that what's left over, not shaded, is our overall solution region. Okay? And if that's causing your head to spin a little bit, that's fine. We're going to get that sorted out later on. So what's happening here is we're going to make two copies of the same graph. So let's say this is the boundary line right here. So this is just a sketch. We don't have to do this to scale. So make one line there, and then copy that slope if you can, and make it appear also on this line, on this coordinate on the right. Okay. So let's say we've determined already that everything above this line, this pane right here, is the true region. True region. That never changes. Like once you determine this is the true region, it stays. It never changes once you determine it. Guys, if this is the true region, then this is false region. Yeah. Automatically. I always figure out the true region and then I know what the false region is. Okay? Same here. True region. False region. Okay? And so if you have a pencil here, this is what happens. If you do regular shading, which is what most textbooks and computer softwares do, and this is a trick here, use your ruler, put it right against the boundary line, and then just shade it like that. Okay. And maybe at the top of this, at the top of where I have regular shading, I'll say that this is textbook. Textbook, for the most part, will use that. We use reverse shading. So what we will do is we'll take the false region and shade that. And you're like, how is that? That's kind of weird. Why would you go against what? Once we do many inequalities, guys, like 2 or 3 at the same time, you'll see why, okay? The important thing is that you label the true region, right? Just make sure you label, and I honestly don't care which shading you use. Let's say you're a rebel, you're like, Mr. Dixon, I don't care what you do. I want to do regular shading. You go to town, as long as you label the true region, okay? But this is what we will use, so we will focus on this one right here. And again, if you label, you're fine using either technique. Okay? Moving on. Dashed versus solid boundary lines. Okay? I will use a highlighter. So if you only have the symbols like this, we have a dashed line going on. Okay? So I'm going to actually use this highlighter. If you come up with a boundary line, we actually make sure it's dashed like this. However, if your inequality is followed by the equal sign, right? Because it's less than or equal to, greater than or equal to, right? If you look at these two symbols, if you have that equal, then we have a solid line. So I'm actually going to make this look different because the boundary lines will vary greatly. This is just to highlight the fact that you may have solid lines and or dashed lines. Okay. What does it say here? I'm going to use a different color. If you have a dashed line, the points on the line are not included in the solution. So whatever points are right on the line, we don't consider them. If it's a solid line, then the points on the line are included in the solution. Okay, I will still do this because I always, so let's say this is the true region. Let's say this is true. I will just focus on the true here. Let's say this is true. Okay. And for now, like on this example, I will still use regular shading because when we only have one inequality, it is fine. So let's say you do this. So what I would be looking for is you having a dashed line there. And over here, it's like that. So the example of this curve, example could be y is less than 2x plus 5, right? So that would be an example of this. An example of this inequality here would be y is greater than or equal to negative 3x plus 4. Okay. So its emphasis is on the inequality. Right? All right. We'll sort this out later. So let's see if you're awake this morning. Would you be able to tell just by looking at this that regular shading has been used? Because the true region that I've labeled is shaded. Right? soon I'm going to transition to reverse, especially when we do multiple inequalities. Okay, another rule. When multiplying or dividing inequalities by a negative, so this is a very important rule, okay? When you multiply or divide by a negative, you flip this symbol. You flip it. And here's why. Would you all agree that 2 is less than 5? Like that's what this inequality is saying. Is that true? Yeah. This is true. By the way, every time you see an inequality, it's asking you a question, right? Is 2 less than 5? In a sense, it's asking a question, and the statement can be true or false. Okay, so this is true. However, let's say you divide both of them by -1. You can treat it as an equation where you do the same thing to both sides. If you divide by -1, you get what? -2 is less than -5. Is this statement still true? Is -2 less than -5? No. This is false. So to account for that, like when we divide by negative, to keep the statement true, we need to flip the sign to do that, okay? So flip symbol, flip inequality symbol. To keep statement true, okay? So therefore, it would be -2, flip it the other way, and -5. Okay. And just to clarify, this is flipped. It's pointing the other way, right? It used to point left, now it's pointing right. Okay, there we go. I think I'm going to skip the test point, because I'm not using test points. If you take a pre-cal 11, they will do test points. By the way, inequalities is in there as well. But I'm going to skip that. I have a better method of doing this. Let's go to this table right here. And I will label this determining the true or the solution. It's the same thing, solution region. Make sure you have this heading or else you will not know what this is, okay? Why is this important? It turns out that when you isolate any of the inequalities and you have y on its own, it turns out that when you end up with y is less than or equal to, the true region is below. Below the boundary line. So I say this in this is the key that I use. T is below the line. Okay? If you end up with y is greater than or equal to, if this is what you end up with when you clean it up, when you rewrite it, I should say rewrite it. You might have to clean up and then rewrite. Then it's above the line. So I say true is above the line. This is very important. I'm going to use this key, right? This code here all the time. Okay. And then these are your special cases. Sometimes you will only have x left over. What kind of a line do we have if it's only x? Horizontal or vertical? It's actually vertical. When you have x only, it's a vertical line. So then it will be, if it's x less than or equal to, it'll be left of line. So true is to the left. If it's greater than or equal to, it's right of line. That's where the true region is found. Remember, that's what we're doing here. So true is to the right. I think I'm just going to leave that. I'm not going to... oh, no, you know what? I will give you the graphs. So when you only have y, or like if y is isolated, then you could have one of these two options. So there's two options here. You could just have a horizontal line. I'm going to use a red pen for that. If it's only y, like you have no x's there, then you have a horizontal line, and the true region is below. Okay? If you have y and x, then it could go this way or this way. It's a diagonal line. True is below. Can you go or here? When it's y, if it's only y, then you'll have a horizontal line. If it's y and x that you have in your inequality, it's a diagonal line. Similarly, same here. Just make two grids like this, two coordinate planes. If you have y is greater than, and you could have a horizontal line like this, true is above. Or you could have a diagonal line like this. And remember, this is your line. The true region is above the line. So it doesn't matter which way it's going, the true region is above the line. Okay? It could be solid or dashed. I didn't do a good job at making some dashed, but I think right now we're just focusing on the true region. Okay? When you have x only, you only have one option. Okay? If you have x is less than, you will graph your line, and the true region will be to the left. If it's x is greater than, when you rewrite it, the true region is to the right. Probably a good study sheet entry. I'll give you probably a little summary of this later on. Okay, let's keep going. Let's do some graph and next page, graphing inequalities. For each of the following, determine the intercepts, rewrite the inequality, rearrange it in this form, and then graph using regular shading for now. Shade. True region, solution region, guys, is the same thing. So let's do that. This is the inequality. This is the boundary line. So what I do is I get rid of the inequality for a moment and just turn it, just do an equal sign there, put an equal sign in there. So I'll highlight that. Because I need to have the boundary line, I need to have information about it before I start actually shading in. So clean up. 4x minus 5y is equal to, this one comes over, positive 10, correct? The negative 10 comes over positive 10. Clean up, that's what I will say. Maybe you should do that at home too. Clean up your room. X-intercepts, Y-intercept. I should clean up my garage. It's a mess. To-do list. Do you remember how to do x-intercept? Y is turning into 0, right? So it's just 4x is equal to 10. You divide both sides by 4. X is equal to. I'm going to tell you this. Here it's okay to have decimals because you're going to need this to graph. And just having fractions is not always easy to graph, right? So just turn that into, it's a decimal, it's 2.5. It could be 2.71. It could be anything. But this is for you to graph, so just turn it into a decimal. Got it? We go back, and now we want our y-intercept. We turn x to 0. So you end up with negative 5y is equal to 10. Divide both sides by negative 5. Y is equal to negative 2. So 0, negative 2 is our y-intercept. So we've got that. Box that in. Clean it up, because you're going to, once you have 2 or more, it's going to get messy, okay? We're good? Okay. Moving along. So this is these are your intercepts, okay? So let's graph that. Let's graph it. And let's go, right? X and Y. I already gave you a scale, so no worries there. 2.50, 0, negative 2. Okay. Actually, I won't graph it yet, because we have to decide, is this going to be a solid or a dashed line? What do you think this is going to be? Do you remember this from the previous page? It's going to be a dashed line. So before I graph it, I'll just rewrite. And I rewrite the inequality, right? Y is equal to mx plus b. And I know you're seeing the equal sign there. Just disregard that. Okay, so it's the 4x minus 5y minus 10 is greater than 0. And you want to isolate y, okay? Just like before, you want to isolate y. So I bring this over to the other side, and I bring this term over to the other side. So you end up with negative 5y is greater than negative 4x, right? Negative 4x plus 10. Because remember, there was 0 on the other side. There was nothing there. So now it's negative 4x plus 10. And what do I need to do next? Divide by negative 5. And that should ring a bell. If I divide by negative, what needs to happen to the inequality? It needs to flip. Okay, so I'm going to use a different color and just say this one needs to flip. So instead of pointing this way, it's going to point the other way. Okay. And then it's just y. And this would be -4 divided by -5. That is just +4/5, correct? X. 10 divided by -5 is -2, which is what I suspected anyways. I suspected that -2 there. So there are 3 things that I will tell myself after rewriting this, okay? This thing tells me 3 things. That this is a dashed line. How do I know that? Because of the inequality, right? Because it's just less than. The true region is, where's the true region? If it's y is less than. Remember I give you that little table? Just focus on that. Where's the true region? Below. Yeah, is below. So watch what I'm going to do from now on. I'm going to say true is below. Like that's all I'm going to do, like moving forward. I won't always write this all down, okay? And where am I going to shade? Shade below. I'm going to shade below the line because I'm using true regular shading. So 3 things that I can derive from the inequality like this. Okay? So let's graph it. I got to go to the 2 intercepts that are going to help me graph the boundary line, and I'm going to go dashed. The nice thing is if you make a mistake if you go solid, you can always just erase a few sections and then you turn it into a dashed line, right? So this is your dashed boundary line. And I will label the true region. It's below the line, right? So if this is the line, below the line is true. Okay. That's what this is telling me. So you grab your ruler and you shade that region for now. True or solution? True / solution region. Let's say you were like Mrs. Erickson, you told me, I looked at my notes, you said reverse shading is when I shade this region up here. And I shaded that. I don't care as long as you tell me where the true or solution region is. Okay, that's all I really care about. I understand that you're using reverse shading if you shade the false region. Okay, I understand that. So do you need to shade label false? You don't. You just have to understand that this is the false region. Any solution in here, any point you pick from here is not going to be a solution to this inequality. Okay, so let's imagine for a second I did not give you a graph and I asked you, is 40/30 part of this, is it a solution to this system, to this inequality? Where is 40/30? 40/30 is like way over here, 40, and then 30 would be way up there somewhere. Is it part of the solution? Show work, you have to actually show work for this. So the inequality, you grab the original inequality. That's the one I would grab. I would grab the original inequality. Okay? Sub in. Okay? You need to substitute in. So this is x and this is y, right? So you'll go 4 times 40 minus 5 times 30 minus 10 is greater than 0. If you do this, you get 160 minus 150 minus 10 is greater than 0. 160 minus 150 is 10. Minus 10 is 0, right? Is 0 greater than 0? No. This is false. Therefore, not a solution. So what are you looking for? You're looking for a true statement, right? When you plug in and you get a true statement, it's a solution. If you plug it in and the statement that results is false, that point is not a solution. Simple as that. Let's do one more. 4 times negative 20 minus 5 times 50 minus 10 is greater than 0, right? So we substitute this in for x and y. That'd be negative 80 minus 250 minus 10 is greater than 0. This is going to be negative 330, negative 340. I mean, come on, right? This one is not a solution. And let's see, negative 20. I think we could have probably looked at our graph and have already determined that, right? Negative 20, 50, like you're going to be way over here somewhere. You're definitely in the false region, right? Can you give me an example of a solution? One example. Negative 5, negative 10, would that work? Anything in here works. Can I pick something that's right on the line? No. It's in this case because of a dashed, this dashed line doesn't look very dashed, right? But because it's a dashed line, nothing on the line would actually work. And you could test that out by doing this and verifying that. Okay, I'll do one more. And then I'll give you class time to practice this. I need you to get really good at this. Okay? What about this one? Note no y variable. I want you to know that right away, right? Sometimes you have to clean up to find out that that's the case, but in this case you don't need to do anything. No y variable. Therefore, this is going to be a vertical line. Make a note of that, okay? So let's clean up. We're going to go 3x. This x comes over to the other side. Minus x is less than 6. 2x is less than 6. Divide both sides by 2. X is less than 3. Please, do I need to flip the inequality in this case? I'm not dividing by a negative, I'm not multiplying by a negative, so no need, okay? Also, you don't need to find the intercepts. Like, it's actually very easy to do these ones because no need, okay, to find intercepts. So in case you're wondering, so is the x and the y-intercept, why aren't you doing that? No need. When you figure out that this is just a one variable situation, let's see what we can deduct from this. This is going to be a dashed line. True region is, if it's x is less than, go to that cheat sheet that I gave you, that little table. True is to the left. So I'll do this from now on. True is to the left, so I know where the true region is. I'm going to shade left because I'm using regular shading. So this is my little symbol for that is just saying S left. So true is to the left, shade to the left. Okay. Where is this line going through? If it's positive 3, guys, it's going through this point right here where x is equal to 3. So you go put your ruler on there and then just dash it along. Dashing through the plane. Anyways, I tried something there. X, Y. Make sure you label everything, okay? I'm already giving you a grid. So this is your boundary line, and I label it using, I didn't do that on the previous example, I have to go do that yet. What I'm doing, I'm going to put the inequality right at one of the ends of the boundary lines. That's what I end up doing. We're gonna say that this is true, and then we're going to go ahead and shade it. Okay? And don't go shading too much. Like if I can see that it's the area you're selecting, I'm fine. Like otherwise you're gonna not be able to recognize anything afterwards, right? Like any labels or whatever will be hard to see, okay? There we go. That's how you do one of those. Is 4, 7 part of the solution? 4, 7 is over here. It's not a solution, right? We know that already. But let's say I don't give you a graph. You just take the original, just in case you make a mistake. Okay? And we only have x's here. Okay? So we plug this 4 in there, and we plug the 4 in there. So it's 3 times 4 less than 4 plus 6. So 3 times 4 is 12. 4 plus 6 is 10. This is false. Therefore, not a solution. I'm going to ask you to just go back to page 19. We're going to label that inequality with the appropriate inequality that goes with the graph. So you decide. I'm gonna pick the original in this case. 4x minus 5y minus 10 is greater than 0. That's what I'm going to label this inequality with. So make sure you do that. And for now, I'm going to stop torturing you. I'm just going to ask you to go try 23 and 24. Page 23 and 24. If you want to go further, you go for it. And I'll post a key to that as well. So this is page 23 right here. What I would recommend every time is this. Intercepts. Hold on. Back up. I'll recommend this to you. Clean up if necessary, if applicable. So meaning bring stuff over so you only have x, y, and a number. Then find the intercepts. Then rewrite the inequality so that you end up with y is greater than mx plus b. Please don't think they're always going to be greater. This is just an example. And then graph. This is what I'm going to suggest every time for all these questions. This is what I would suggest you follow. Check if there's a special case. Is it a horizontal line? If it's only y, guys, it's going to be a horizontal line. If it's only x, it's going to be a vertical line. No need for intercepts. No need. Like, it's actually much easier if you recognize that. Okay. I'll let you work.